The problem that I'm going to solve is very similar to the problem where we were going to decide whether we should order a product alone or combine it with another product or combine it with the third or combine it with the fourth product. The ordering cost was not proportional to the number of products. It had a fixed cost and then a variable cost which was associated with the number of products. Here, we almost have the same logic. Indeed, we exactly have the same logic, but here we consider trade-off between transportation cost and inventory carrying cost. A retailer chain has 8 stores. Truck has capacity of 40,000 units of product. For simplicity, demand of all retailers are equal and is 960,000 for each store. Later, we also consider the situation when the demand for each store is 120,000. Fixed cost of transportation is $1,000 per trip. If it is delivered to only one single destination, $100 will be added. If it is delivered to 2 destinations, then 2 times $100 will be added. This problem is also a comparison between direct shipment when the truck goes, put the load and comes back, or milk runs when the truck goes to the first destination, second destination, third destination, and then come back. Direct shipment to a single destination or milk runs to more than a single destination. If we draw the transportation cost based on the number of destinations, we will get a fixed cost of 1,000 plus a variable cost of 100 per destination. But if I divide this cost by the number of destinations to find out the cost of each destination, then the curve goes down like this. If you have 1 destination, shipping cost per destination is this one. 2 destinations, shipping cost per destination is this much, and this is for 3. There is a steep drop here, but gradually the curve gets closer to a flat shape. Inventory carrying cost is 20 cents per unit of product per year. Let's consider the case of 1 shipment. This is the shipment cost. So we have shipment cost, which is fixed cost, and we have carrying cost per unit of product, and demand of each of retailers is the same, and it is this much. Therefore, I can simply put it into EOQ and compute EOQ. And in this situation, EOQ comes up 102,000 units, which is far more than the capacity of the truck. And we don't have a truck with this capacity. Therefore, what we can deliver is 40,000. And if I divide 960,000 by 4,000, I would get 24 shipments. And to get the cost of 24 shipment, I simply multiply this one by this one. Total cost of shipment. Each truck delivers 40,000 units of product. Therefore, the average inventory, the cycle inventory would be half of that 40,000. And if we multiply this one by cost of carrying 1 unit of product per year, we will get 4,000. Transportation cost, inventory carrying cost. We add them together, that is the total cost. This is the total cost. For 1 retailer, if we multiply it by 8, it will be for all retailers. Now let's milk runs with 2 destinations. This value will become 1,000 plus 200, which is 1,200. If I divide it by 2, that would be 600 per retailer. Now I have S equal to 600, H equal to 0.2, and destination has a demand of 960,000. Each destination has that much demand. I simply put it into EOQ model. Let's adjust these numbers. 2, so that is 600. This is this one, and we have this one, and therefore EOQ comes out this much, which is greater than capacity of the truck, so we stay with the capacity of the truck. Capacity of the truck is 40,000, but now it should go to 2 destinations. Therefore, what is available is 20,000. And therefore, if I divide demand of a destination by what I deliver to that destination, I realize that I need 48 shipment. And cost of each shipment for that destination is $600. Therefore, this is the shipment cost. Because I delivered 20,000, if I divide it by 2 as the average inventory at the destination, average inventory is 10,000. And since carrying cost is 0.2, this would be my carrying cost. Carrying cost, shipment cost. The total cost, carrying plus shipping, is 30, and when we multiply it by 8 retailers, we get this number. Now let us change the demand to 120,000. 120 is our demand. Transportation cost has the same feature. Inventory carrying cost, truck capacity. If we deliver to one destination, our fixed transportation cost is 1,100, and our EOQ is this much. This EOQ is less than the capacity of a truck, so we can deliver it. In that case, demand divided by EOQ leads to 3.3, and if we multiply it by the fixed cost, we will get this much as our transportation cost. Average inventory or cycle inventory is half of this value, which is multiplied by the carrying cost per unit per year, and it becomes this one. If I add carrying cost to the shipment cost, this is total cost for one destination, and this is total cost for all 8 destinations. Each of them get direct shipment. There will be no milk run. 58,131. Now let's try 2. Total transportation cost divided by 2, that is the fixed cost of transportation retail. And we compute EOQ based on this S, and based on this H, and based on this D. And we get 26,000, which is more than the share that 2 retailers could have in one truck. 2 retailers each could have 20,000 in one truck. Therefore, we need to stay with this one and deliver 20,000 per retailer. If we deliver 20,000, we need 6 shipments. And if you multiply each one by that cost per retailer, we will get 3,600. 20,000 is delivered to each retailer. Therefore, on average, they will have half of it. And then the carrying cost is this much. We add shipping cost to carrying cost. It is this much for one retailer, and this is for 8 retailers. Let's also consider milk runs to 4 retailers. Everything is the same up to here. Because I have 4 retailers, this would be total transportation cost. And since they are 4, this is the share of retailer. Computed EOQ based on this number gets me 20,000. Share of this retailer in this truck is 4,000 divided by 4, which is 10,000. Therefore, if I am going to deliver 120,000 units in shipments of 10,000, I will have 12 shipments. If I multiply each one by the cost, the fixed cost of transportation per retailer, I get 4,200. And because I deliver in batches of 10,000 units, therefore half of that 10,000 units on average will be in the warehouse of the retailer. And if I multiply it by its cost, I will get 1,000. If I add 1,000 to 4,200, I get 5,200 per retailer. If I multiply it by 8, then I will have the total cost. I can also do this. This one, put it over there. Come here and type equal to this one. I mark all of this. Data, what if analysis, data table. I have typed my data in a column, and that is the number of destinations. So the total cost comes down and then goes up. Thank you very much for attending this session.